Hello, welcome to Technoveda Solutions.
Okay, in this video, we will discuss about the LCD interfacing with Cortex M4 ARM based microcontroller. So now coming to IDE. So here you can see first we have included the header files, std, integer, and stand header files for the STM32. These are all prototype declarations. We'll see each one function, what are the definitions we are doing it, what implementation we are doing in each function. Then these are two macros defined, one for high and low for the LCD signaling. And then in the main function, we are calling the different functions and we have nothing inside the while loop. Now we'll see how exactly the implementation of these functions happen one after the other, and we try to understand how LCD is going to work. Now first we have to initialize the GPIOs for the LCD. So coming to a GPI initialization function of the LCD. So we'll be first initializing our PC4 and PC5 of the AHB1 ENR register, that is port C is enabled. And once we enable the port C and using a mode register, we are going to configure PC4 and PC5 in the output mode because that is where the LCD is connected. So our LCD is connected to PC4, PC5, PB 12, 13, 14, 15, and PB 3 and 4. So these are the GPIO pins which we will be using for the LCD data transfer, and the PA0 and PA1 are used for the control signals. Now first, if we want to understand how exactly an LCD works, so first we'll have a brief discussion on that. I will just take you to the LCD, how it looks like. So if you see here, the LCD has 8 data lines. So we need to connect the data lines to these pins from the microcontroller. Then of course we are going to give a power supply for the LCD controller. So VDD is connected to power 5 volts and VSS is connected to ground. So these are the three control signals we have: RS, RW, and E. RS is register select, RW is read write operation, E is enable operation. Now this RS signal is used to select the data what we are sending on D0 to D7 should be considered as a command or should be considered as a data by the LCD controller. That is indicated by RS signal. If RS bit is 0, then whatever the bit stream we have on D0 to D7, that hexadecimal value is considered to be a command to format the display on the LCD. Whereas if RS bit is set to 1, then whatever the bit stream we have on D0 to D7, that will be considered as an ASCII value of the character to be displayed on the LCD. Then RW signal is used to define whether we are going to write on the LCD or we are going to read from the LCD controller. So here we are going to do a write operation. So RW is connected to ground, and then we have another control signal, that is enable. Once we configure all these RS bit, RW bit, and we put the data on D0 to D7, then we have to give a small pulse on the enable pin so that it will indicate the LCD controller to read the data lines. That means whenever we give a pulse to enable signal, only then the bits on the data line are read by the LCD. So we should make sure that before we give a pulse to enable, we configure all the control signals and we put the data on the D0 to D7 lines. Then we just give one pulse to enable. Now to do that, we'll try to program. For that, we are defining GPIO-C, GPIO-B, and GPIO-A. All the three GPIOs we are going to use. GPIO-A has a control signals, and GPIO-C and B have a data lines. So total 8 data lines are connected. So all are defined as a output. So all defined in output mode of operation. Then once we do that, then we have to initialize the LCD. So first we go to LCD initialization function. If we come to LCD init function, here we can see that we are sending the command words here. So first command word is 0x01, that is to clear the display. Then we send 0x08 is another command word that defines two lines of a display with a 5 by 7 matrix. Since this 5 by 7 matrix is a dot matrix to display each of the character, I will show you when it is actually displaying on the LCD. I will show you how it is exactly 5 by 7 and what is 16 by 2. Both matrix I will explain when I go to that particular display. Then we have 0x06 command, that is to display the cursor and increment the cursor to the first location. Then 0x0c is to display on and cursor off. So for all these we are giving a 0 as a second parameter, indicating that these are the commands which will format the display and not the ASCII value to be displayed. So these are the commands which will format the display. Then once we initialize the LCD, then we can just send a command to the LCD function. So here we are sending 80 as a command with the 0, low is 0. So this is also a command word. So now we have two command words, 80 and C0. 80 will display the characters on the first row, and C0 will display the character on the second row. Now we can have 80 to 8F to define the column where exactly the display has to come. Similarly, on the second row, we can have C0 to CF to define a column where the characters to be displayed. Now, then we are calling lprint function. So lprint function is used to actually print the character. We are sending a string to lprint. So this is the lprint function. So we are sending a string, and then we are capturing that in the string pointer. And inside the while loop, we are checking the characters of the string and we are sending that to LCD till we reach the null character. So null character indicates the end of string. So till we reach the null character, we are sending the character one by one to the LCD function. So if we observe this LCD function, so this is the LCD function. So there are two parameters, value and the command. When we say a value, this will be a 8-bit value, hexadecimal value what we are sending, and this will be the command. It can be 0 or 1. If we want to send this command as a 0, then the value will be taken as a command and that will be used to format the display. And if the command value is 1, then the value is considered as a data to be displayed on the panel. Now we have to unpack the bits of this value. So data is equal to val and with 0 1. So that will give us LSB in the data. So now if the LSB is 1, the data value will become 1. If the LSB is 0, the data value will become 0. So now based on that, we are setting the bit or resetting the bit depending on the value of the data. So this is the LSB, this is first bit. Then we are shifting the value by 1 and then again ANDing with 1. So now when we shift it by 1 and AND with 1, we will get the first bit. Here we got the 0th bit. So here we will get the first bit. For example, if I have a value say 10000000, that is 80, then first I am masking this bit. This particular bit is masked and that bit is checked here. Then in this case, when we come to this instruction, here we are shifting the value by 1. That means we are checking this bit. So this bit is shifted 1 and then ANDed with 0 1. So this first bit is checked, and if it is 0, the data will become 0. If it is 1, the data will become 1. Now similarly, we will be shifting it by 2, then we are checking this value, then shifting by 3, then shifting by 4, then shifting by 5, 6 and 7. Like that we are shifting the value of this value bits and we are ANDing that with the 1, so that we'll get this bit value in the data variable. Now, based on the data variable, each bit we are setting with 0 or 1. Now, as we know that how the bits are connected to the LCD, accordingly the code has to be written. So PC4 5 are D0 and D1. Then we have port B, PB0 and PB1, that is data 2, 3, D2 and D3. Then we have PB12, 13, 14, 15, starting from D4 to D7. So these are the 8 data lines. Now, once we set the bit stream on the data line, whatever the bit stream we have, we are setting that on the data line. Then we have to check the value of this command. So that we are checking here. Once we set all the 8 bits, then we are checking whether the bit stream what is available on the GPIO pins is a command to be formatted on the display, or it is a character to be displayed. That is indicated by this CMD variable. If CMD variable is 0, we'll set the control signal to 0, indicating it's a command. If CMD bit is 1, then we'll set the bit to 1, indicating it is a data to be displayed. So this will set the RS signal. If RS signal is 0, then the bit stream what we have put on D0 to D7 will be considered as a command to format the display. And if the RS bit is 1, then the bit stream what we have put on the D0 to D7 is considered as the ASCII value of a character to be displayed on the display panel. So we are setting the GPIO signal. Once we configure all these bits, then we have to give one pulse on enable signal, that is PA1. We are just making it high with the delay making it low. So we are giving it a small one pulse. First initially it is low, then driving it to high, then give a delay, again drive it back to low. So this is a pulse given there. This is how we read the data on the LCD controller. Now we have another function. This is a print. This function is used if you want to display a numerical value. So for numerical value, we'll be unmasking the value sent with the D1, D2, D3, D4, unmasking each character. Then the value of that will be added to 30. That is, we know that the ASCII value of 0 to 9 numerical values is from 30 to 39 hex. So by adding 30, we will get the ASCII equivalent of the digits. So we are unpacking the digits of a decimal value here, and we are adding 30 to get the ASCII value of that. And that ASCII value will be sent to the LCD function with CMD as 1. If CMD is 1, we know that it is going to be a data to be displayed. Whereas if you see other cases, when we are sending a command, always we send the CMD value as a 0 here, that is low. This is how the LCD function operates. Now let's compile the code. Okay, so we have successfully compiled with 0 error and 0 warning. Now the hex file is generated here. So this hex file we are loading on the Proteus. Let's go to Proteus. So now this is the Proteus. So we have selected the microcontroller STM32F401RD. So now you can see here, the first we are connecting the control signal PA1 and PA0 to RS and enable pins, and RW is connected to ground. So RS is connected to PA0 and EN is connected to PA1. Similarly, we have data lines. So here we have data lines, PB0, PB1, and then we have PC4, 5 and PB12, 13, 14, 15. All are connected to D0 to D7. So here we can see all the connections, how it is done. Then the power supply is connected, so wherein we are connecting VSS to ground and VDD to 5 volts. Now let's load the microcontroller with the code. So if we browse, so we are going to get here and debug. So we'll get a hexadecimal file here. So let's open that and then click OK. So hex file is loaded. Now if we run the code, it should display hello world here, hello world. Now you can see that for hello world, first we are giving 0x08, that is in the first row, and 0x0c0 in the second row. Now suppose I want to have a display on this somewhere offset. Now let's give the offset. Say I, instead of giving 080, I will give 86, and here I will give CA. Okay, so I've given offset on both first and second row. Here I've given a sixth column, and here I've given a 10th column. Now let's compile the code, and now I will load the code again. I will just stop the execution. I will load the code again. Now if I run, it should display with the offsets. See, now you can see it has displayed with the offset of 6, and word is displayed with the offset of 10 columns. Like that, we can configure this command from C0 to CF and 80 to 8F to display on first row and a second row with the offsets. So this is how we interface a LCD with a STM32 controller. Hope you understood the program, and you like the video. Please click on the like button, and subscribe to the channel and share the video with your friends. Thank you. Have a good day.